So we've now converted from mass to moles to particles. But what if you are given the number of particles and you are asked to convert it to mass, or you're given the number of particles, but we can't sit there all day and count particles. We need an easier way to get the same amount of particles. And the only way we can do that is using a scale balance in our chemistry laboratory. So if you have particles, you can't go make a direct translation. There is no conversion to do that. You have to convert it from particles, you need to go to moles, and then from moles, you need to go to mass. So if you are given 8.03 times 10 to 23 atoms of fluorine, how many grams are there? So now we know the number of atoms. We need to find out in mass how much fluorine would that be. So you take what you are given, you want the grams of fluorine, and your conversion is now from atoms to the number of moles to the mass. So for every 1 mole of fluorine, you had 19 grams. So this question should watch out. This one just says fluorine, so we're just talking about a single fluorine. Okay, if it was fluorine gas, you'd have to double that. Here you have 8.03 times 10 to the 23 atoms of fluorine, times it by, we need to now go to moles. So how many atoms is in 1 mole of fluorine? You guessed it, 6.02. So my atoms of fluorine will cancel out. I want to convert it to moles, so moles need to go on the top. So atoms of fluorine cancel out. I now have moles, but I don't need moles. I want to find grams. I can't mass moles in. I don't have a scale for that. So I got to take a look at my conversion factor here from my atomic mass unit, or mass per mole. So I want to cancel out my moles. I now have 19 grams of fluorine, so that will equal 25.3 grams of fluorine. Let's take a look at another, we won't look at another example, but practice some more questions in on your sheet, and we will work on some more of these types of problems in class tomorrow.